Welcome to part 38 of our series on building a Zelda-like game in Phaser 3. In this video, we'll introduce a data manager to handle game-wide data like player health, inventory, and game state. We'll create a data manager class, implement getter and setter methods, and connect it to the preload and game scenes. We'll also update the chest class and handle player damage and death. If you're new here, this is part of a full series where we create a Zelda-inspired game from scratch. Check out the playlist link in the description to start from the beginning. Alright, let's dive in and implement our data manager. In the last section, we build out our combat system, allowing the player to attack our enemies. With that in place, we now need a way to manage key gameplay data, like our player's health, our player's current location, and our dungeon progress. In this section, we'll introduce a data manager to track and store important game data, making it easier to manage things like our health, our location, and our world state. Later on, our data manager could be extended to allow us to save our game state. Alright, let's dive in and start building our data manager. To start creating our data manager, let's go into our source code. Under our source folder, under common, let's make a new file. We're going to call this data manager. Let's export out our class. We'll call this data manager. So for our data manager class, this is going to be responsible for keeping track of our overall game state. This is going to be different than our inventory manager that is solely responsible for keeping track of our items our player has collected. Our data manager will keep track of things like our player's current health, what their max health is, where our player is currently at in our game, and then it's going to keep track of our state of our various areas. So as our player starts navigating our dungeon and doing things like opening up our chest, unlocking doors, we'll need to keep track of that state. That way if our player leaves our dungeon and comes back, or if they die and respawn, we'll be able to update our dungeon state to match what our player's already done. Later on, we could then take this information and do things like save it to our local storage. That way we can allow our player to save their game and come back and pick up from where they left off. So for our data manager, this is going to be similar to our inventory manager, where we'll want this to be a singleton, and we'll only ever want one instance of this class running for our game. To start adding our code, first we'll make our class a singleton, so let's jump over to our inventory manager. Let's copy our public static get instance, our constructor, and then our class properties, and then we'll remove what we don't need. So now for our instance, we'll want to set this up as our data manager. Let's get rid of our two properties. Now for our constructor, we'll leave this empty. Now for where we get our instance, let's update our class. Now for our class, we need to define our data that we want to keep track of. For this, we'll add a new private property. We'll call this data. And for our type, we're going to call this player data. And now we'll define that type at the top of our class. And so we'll do export type. We'll do player data. So now in our constructor, we'll want to initialize our objects. We'll do this, that data will be equal to our empty object. So now for our player data, we'll want to keep track of our player's current health and their max health. So let's add those in. Both of these will be numbers for our type. Next, we'll need to keep track of our player's current location. For this, we're going to call this current area. We're going to make this an object. And now we'll need to know which level our player is currently in. So are they in our dungeon or are they in the main overworld? So for our type, we'll do level name. Next, we'll need to keep track of our room ID and our door ID. So now for our room ID and our door ID, we want to keep track of where our player needs to start at for this current area. So typically in Zelda games, when you die in the dungeon, you don't respawn right back where you were at. You would actually respawn back at the beginning of the dungeon. To keep track of that, we'll need to know what that door and room ID is, so then we can spawn our player at that location. So we'll add in start room ID. This will be a number, and we'll do our start door ID. And then it'll also be a number. Now we'll need to keep track of what we have accomplished in our areas. So for our dungeon, this will be keeping track of things of which chests we have opened, which chests we've revealed. If a door was locked, have we used a key to unlock it? And if we actually beat the boss for this current dungeon. To keep track of that information, add in a property, we're going to call this area details. This is going to be an object. And now this object will want our key to match our keys from our level name. So for this, we're going to do our key in level name. And now this will allow us to have an object where our key will match our level name. And so we'll have values like our world or dungeon 1 to keep track of those stats. So now for our area object, we'll want to keep track of our chests and our doors based on which room they're tied to. So for that, we'll add in a property, and we're going to do our key, and this is going to be a number, which will be our room ID. And now for this object, we'll have our chest, and then we'll have our doors. Now for both of these objects, we'll want our key to be our ID of that chest or that door. And so for our key, we'll make this a string. And now for our type, this will be an object. And now for our chest, we want to keep track if we've actually revealed it. And so this will be a Boolean. And then we'll keep track if we've opened our chest. And so this will be a Boolean. Now for our doors, let's copy our object from our chest. But the only property we need to keep track of is if we actually unlock one of our doors. And so we'll do unlocked, and that'll be a Boolean. Finally, for our area details, we'll want to keep track if there was a boss and if we've actually defeated that boss. And so we're going to do boss defeated. So we're going to make this optional, and this will be a Boolean. And so for some of the areas in our game, we might not have a boss, and so that's why we made this optional. Now that we've defined our player data type, we need to update our instance inside our constructor. Let's start with our player health. So we'll have our current health. For this, we'll want to reference our player start max health from our config. And so we'll do our player, we'll do our start max health. Now for our max health, we'll set it to the same variable. Now we'll do our current area. So for our current area, we'll want to match this to our data that we're currently setting in our preload scene. So for our name, let's do our level name. We'll do our dungeon 1. Our start room ID, we'll do 3. And our start door ID, we'll set that to be 3. Now we need to add in our area details. Now this will be an object. We'll add in our dungeon 1 first. For this, we'll do our boss defeated. We'll set that to be false. And now let's add in our world. And for our world, we'll do our empty object. So when we initialize our area details, we don't need to populate each of our room IDs that we already have. Instead, when our player takes action in our game, like revealing or opening a chest, we're going to add methods to our data manager class that will allow us to add those objects when we need them. So now that we've initialized our player data, next for our class, let's add our getter and setter for getting our data. Now that we've initialized our player data, next for our class, let's add in our getter and setter for our data property. So first we'll do our getter, so we'll do get, we'll do data. For our return type, this will be our player data. And for this, we're going to return a copy of our data, so we can't modify it. And so we're going to do this, and we'll do our data. Now for our setter, we're going to do set data. For our argument, we'll have data, and this will be our player data. And now we'll set this, our data, and it'll be equal to a copy of that data. Finally, for our class, we just need to expose some methods that will allow us to update our data in our data manager. For this, we're going to add in methods that allow us to update our area data, update our chest, and our door data, and then finally to reset our player's health when our player dies. So for our first method, we'll call this update area data. So we'll do public update area data. Now for our arguments, we'll need to know the area that we're adding. So this will be our level name. They will need our room and our door ID. And so we'll have our start room ID. This will be our number, and we'll have our start door ID. For our method, we won't return anything. Now we just need to update our current area. So we're going to do this, our data, our current area. This will be equal to an object. For our name, we'll do our area that we passed in. We'll have our start door ID and our start room ID. Next, we'll add in a method for updating our chest. So we'll do public, we'll do update chest data. Now for this method, we'll need to know which room our chest was in. So we'll have our room ID, this will be our number. We'll need to know our chest ID, which will be a number. And then we'll need to know the state of our chest. And so we'll do revealed, make this a Boolean. And then we'll do opened, and we'll make that a Boolean. We'll return nothing from this method. So now when we call this method, first we'll want to make sure we actually have that room ID as part of our area details for our current area. If we don't, we'll need to add that to our object. And so we'll do if this, our data, our area details, we'll get a reference to where we're currently at. So we'll do this, our data, our current area, and then our level name. And if our room ID on that object is equal to undefined, that means we've not done anything inside that room yet. Now we need to add that room to our object. So I'm going to copy this line of code here. Let's paste it. And now we'll set equal to an object, and we'll have our chest. This will be an empty object, and then we'll have our doors, and that'll be an empty object. So after our check, now we can update our area details. So we'll do this, we'll do our data, our area details. We'll grab our current area. We'll grab our level name, and we'll use the room ID that was provided. And then we'll reference our chest objects. And now we'll use that chest ID we provided, and we'll set our state equal to our state that was provided. So we'll have revealed, and then we'll have opened. Now we'll want to do the same thing for our doors. So I'm going to copy this block of code here, we'll paste it, and we'll update our method name, and we'll do update door data. So we'll need our room ID, we'll need our door ID, and then we'll just need to know if our door is unlocked. So we'll update our property here. Let's get rid of open. And so we'll want to do a similar check where we populate our area details for the room that was provided if it doesn't exist on our object. Finally, we'll update our property. And so instead of doing our chest, we want to do our doors, and now we want to do our door ID. And then we'll just set unlocked. Now, since we're doing the same set of logic in both of our methods, we'll move this to a new private method. And so we're just going to do private, and we'll do populate default room data. For this, we'll need our room ID, and this will be our number. We won't return anything for our method. Then we'll grab this block of code. Let's paste it here. And now we just call our new method. And so we'll do this. We'll do our populate default room data, and we'll pass in our room ID. Let's copy that line of code, and we'll update our other method. Finally, we just need to add a method to allow us to reset our player's health. So typically in Zelda games, when your player dies, they don't actually restart back at their max health. Instead, they would restart at a minimum threshold. And so this would typically be like 3 hearts. And so to add in that method, we'll do public. We'll do reset player health to min. We won't return anything. We'll just do this, our data. We'll do our current health. We're going to set it equal to our player, our start max health. Now that we have our new data manager class, we need to start connecting it to our game. To start with, let's go into our Preload scene. And instead of hard-coding our starting level and our room and door ID, we're going to grab this from our data manager. So we'll get rid of our to-do here. Let's update our level. We'll do our data manager. We want to grab our instance. Then we'll grab our data. Let's grab our current area, and we'll grab our name. Let's copy that line of code. We'll update our room ID and our door ID. So now if we do our starting room ID, and then our starting door ID. Alright, so we save, and our game refreshes. Our player should still spawn inside our dungeon, in our room 3 at our door 3. And if we leave our dungeon and come back in, everything should still be working. Now that we've updated our preload scene to use our data manager, we need to do the same thing for our game scene. So in our game scene, we have a few spots where we'll need to integrate our data manager. Our first is when we go to spawn our door and our chest game objects by parsing our data from tiled, we'll want to grab our data manager and check to see if we previously already revealed a chest or opened it, and if we've already unlocked a door. If we have, we'll want to update the state of those objects to reflect that. Then that way our player doesn't need to repeat those actions. Next, as our player interacts with these objects, we'll need to update our data manager's state. So as an example, when we collide with our boss door, if we had our boss key and unlocked it, we'd want to update our state so then it reflects that. So to start with our changes, let's go to our register colliders method. Let's come down to our collider where we check for our collision between our player and our doors that can be unlocked. So let's start with our small doors. So after we use our small key and we open up our door, now we want to update our data manager, and so we'll do our data manager. We'll grab our instance. Let's call our update door data method. And now we need to provide our current room ID, and then the door ID that we just interacted with. So we'll do our door, our ID. We want to set to be true since we unlocked that door. Let's grab our comment for our data manager. This should actually be inside our if statement, and then we'll remove our to-do from our comment. Now we want to do the same thing for our boss doors. And if we open up our boss door, we'll pass in our current room ID, the door ID of that door, and we want to set to be true. So we'll update our comment. And now we'll want to do the same thing when we open up one of our chests. So let's go to our handle open chest method. So in our method, let's get rid of our to do. We'll paste in our line of code for our data manager. Let's update our method name. We'll do update our chest data. So we'll want to pass in our current room ID. Now we'll want to pass in our chest, our ID, and we'll want to say true because our chest should be revealed if we're opening it, and we'll do true when we open up our chest. Next, we'll need to update our data manager for when we reveal one of our chests. For this, we have 2 different actions. One is when we defeat all of our enemies. The second one is when we press a switch to reveal our chest. So let's go to our handle button press method. So after we reveal our chest, let's update our data manager. So to our data manager, our instance, we'll do our update chest data. Now we'll grab our current room ID. We'll do the ID of our chest. And now we want to do revealed. We'll set it to be true. And we'll do false for if our chest is open. So now before we update our data in our data manager, we're going to want to check to see if we already have existing data for our chest data. The reason for this is we can press our buttons multiple times in our game, and so when our player enters into our next room, when we press our switch to reveal our chest, that's when we want to update our data manager. Now, after we reveal our chest, our player could leave our room and come back in, and if they do, our chest is already revealed. But if we open our chest and then we press our button to reveal our chest again, we're going to override that state, and now we'd say we didn't actually open up our chest. And so to handle that case, we'll first want to grab our data, and if our chest has already been revealed, we won't bother setting this information. Let's make a new variable, do const, we'll do existing chest data. For this, we'll set it equal to our data manager, our instance, we'll do our data, we'll use our area details. Now we're going to grab our current area name, so we'll do our data manager, our instance, our data, our current area, and now our name. And now we'll reference this current room ID. And since our room might not exist in our data yet, we'll do our optional chain, and now we'll do our chest. And from here, we want to grab the ID of our chest. So now, if we don't have our existing data, or our existing data, if it's not been revealed, now we'll update our data manager. Now we just need to add in the same logic when we handle when all of our enemies are defeated for one of our rooms. So let's copy this block of code here. Let's go to our handle all enemies defeated method. So under our to do, we'll paste in our code. Now we just need to update our references. So we'll just do our chest, and then an ID of our chest, and then same thing here. And finally, when we're creating our door and our chest game objects, we'll want to grab our data from our data manager and then update the state of our game objects. Alright, so now in our create doors method, after our check where we see if we have our door object, we'll want to see if we have existing data for this door, and if we do, if our door is unlocked, then we want to open up our door and we can return early. Then that way we don't add our door object to our locked door group. So to add in that code, let's paste in our code for our existing chest data. We're going to update our variable name, we'll do existing door data, and now for our reference, instead of doing our chest, we want to do our doors. We'll pass in our tiled object, and then we'll pass in our ID. So now in our if statement, we'll do if our existing door data does not equal undefined, and our existing door data, if our door is unlocked, if that's true, now we want to open up our door, and so we'll do our door, and we'll call our open method. We don't need to update our data manager, but we can return early, and then that way we don't add our door object to our two groups. So now let's copy that block of code, and now we'll do the same thing when we create our chest. So we come down to our create chest method. After we add our chest to our blocking group, we'll paste in our code, and so we'll do our existing chest data. We'll update our reference, so instead of our doors, we're going to do our chest. This now on our check, we'll do if our existing chest data does not equal undefined. Let's get rid of this part of our code here. And so if our existing chest data is not undefined, now we'll want to see if our chest has been revealed and if it's been opened. And so if our existing chest data, if it's been revealed, we'll call our revealed method. So we'll do chest reveal. And now we'll see if our chest has been opened previously. So we'll do our existing chest data. We'll do opened. And now we'll do chest and we'll do open. We can get rid of our return statement and then let's save. Oh, one change we need to do to our create chest and create doors methods is when we grab our existing data, we don't want to use our current room ID. We want to use the room ID that's associated with the room where we're creating our objects at. So if we come back up to create doors, let's update our reference there as well. And so we'll do our room ID, and now let's save. All right, so if we save our code, we should be able to test our changes. And so now for testing our data manager, we want to test that we're actually persisting our data when we restart our phaser scene. To do that, we'll want to update our data manager and then leave our dungeon and come back in. And then that way, when we recreate our objects, we can verify that we're using the estate from our data manager. So now when we come into our second room, we should expect our chest not to be visible. And just to do a quick test, if we leave and come back in, our chest should still be visible to our player. So now if we open up our trapdoor, let's leave. If we leave our dungeon and come back in, ideally our chest should still be revealed to our player. If we come back into our next room, we'll see our chest is revealed to our player, and we don't need to press our switch to actually reveal it. So now let's test opening up our chest. So now if we leave our room, let's leave our dungeon. If we come back in, our chest should be in our open state. And now if we go over to our locked door, let's do a test with that. So if we open up our locked door, let's leave our dungeon. And so now when we come back into our dungeon, we should see that our chest is open and our locked door is still open. Nice. Finally, for our data manager, we have two other updates we need to make. Our first one's going to be in our chest class. So in our callback, when we're checking to see if we can actually open up our chest or not, we're checking to see if our player has our boss key from our inventory manager. For this, we hard-coded this to use our dungeon 1, and instead we want to use our area information from our data manager. So for this, we'll want to do our data manager. We want to grab our instance, our data. We use our current area, and then we want to grab our name for our level name. And then that way we're referencing where we're at currently in our game. So let's remove our to-do. And then finally, we'll just need to update our player's health after our player takes damage. So currently in our data manager, we have a method for resetting our player health back to its minimum value. And so we'll just need to add a method to update our player's current health. And so we're going to do public. Let's do update player current health. We won't return anything from our method. And now for our method, we'll need one argument, and we'll do health, and this will be a number. And now we can do this, our data, our current health, and we'll set it equal to our health argument that we passed in. So now with our new method, now we just need to update our data manager when our player takes damage. For this, let's go into our character game object class. Let's go into our hit method. And so now after we update our life component to take damage, now we'll need to update our data manager. And so we'll do if this, if it is our player. Now we'll update our data manager. And so we'll do our data manager, our instance. Let's do update player current health. And now we'll just pass in our health from our life component. So we'll do this, our life component. And now we'll pass in our current life value. Finally, for our data manager, our last test we'll want to do is when our player dies, if we respawn our player, our dungeon state should be the same as it was before. So to add in this change, we'll need to add in logic to actually restart our phase or scene once our player dies. To do that, we'll need to listen for our player defeated event. So if we come up to our register custom events method, let's add in a new listener. So let's copy this line of code here. We're going to paste it. Let's do player defeated, and we'll make a new method. And we're going to call this handle player defeated event. Let's copy this line of code. We'll want to make sure we turn off that event listener when our scene shuts down. And so we'll do off. Now let's copy our method name. Let's come down to the bottom of our class. We'll add in that new private method. Now for this method, we won't return anything. And so now what we'll do is we'll fade out our camera, and then we'll restart our phaser scene. To do that, we'll need to listen for our fade out event. So let's reference our main camera. So we'll do this, our cameras, our main camera. We'll do the once method. Now we want to do our phaser, our cameras, our scene 2D, our events, and now our fade out complete event. And now in our callback, we'll do this, we'll do our scene, let's do a restart. And now we need to fade out our camera. So we'll do this, our cameras, our main, we'll do fade out. And for our duration, let's do 1 second. So we'll do 1000 milliseconds, and we want to do black. So we'll do 0, 0, 0 for our red, green, and blue. And so to quickly test our changes, let's go into our config. Let's update our player start max health. We're going to set this to be 3. Now if we come back to our game, let's try revealing our chest. So now if we have our player die in our room, once our camera fades out, we should be back at the beginning of our dungeon. And if we have our player go into our room, we should see that our chest is still revealed. Nice. Alright, so now we verify our changes. Let's reset our starting max health back to 6. Alright, so with that last change, that actually wraps up our data manager. So in our next video, we'll start working on our UI components for our game. That's it for this part of the series. If you found this helpful, be sure to hit the like button. It really helps out the channel. And if you're following along, make sure to subscribe and turn on notifications so you don't miss the next video. If you have any questions or want to share your progress, drop a comment below. I'd love to hear from you. Alright, thanks for watching, and I'll see you in the next one.